start recording the video, so we should be getting video recording here. So the way we're going to do our play blasts, I only have one car in mind, right? But we're going to find a camera angle we like, that we want to show it from, right? So something like this. And then I'm going to right-click on my timeline here, okay? And you'll see the word Play Blast right there. Now, another place we can get to this is under Windows, Play Blast. But I'm not just going to click the word Play Blast. I'm going to go to the Options box, this little box out on the end, okay? And this is where all of our information is on how to save this correctly. If we leave this as AVI, it's going to make an enormous file that's going to play back really slow, and it's not really going to have a reason to be that big. So what I'm going to do instead is if I click on Format and choose QT, then it's going to allow me to make that a little bit more reasonably sized, right? Now, right now, the way it's going to encode it is as a series of PNG images. Anybody ever saved a PNG? It's like a JPEG, right? So what that means is every frame of this animation is going to be the size of a full PNG image. So it's still going to be big, right? And that's not really how I want to compress this, right? Well, what this is, encoding means that we have a whole bunch of pixels that are playing back really quickly on our screen. What algorithm are we going to use to make this file small and still look good, right? And there's only one answer that you'll ever need to know your entire time you are here at college. You're going to hear this phrase over and over and over again, H.264, right? What that stands for, we could look it up. More than likely, usually they name these codecs like JPEG. All of these different things are named after these compression conventions that they establish at certain times in history. JPEG's been around for a long time. And H.264, there's a couple of others. There's an H.261, you'll see it here, and an H.263. We don't want either of those. It's actually a little higher. So if you scroll up, H.264. Now that H.264 is only going to show up if you chose QT under your format. Okay, QT stands for QuickTime. You don't actually have to have QuickTime on your computer to play this file. It should still play in Windows Media Player. In fact, Apple has recently discontinued QuickTime. It's not even a program they support anymore. I don't know why. I actually like QuickTime. Now, I usually turn quality all the way up because H.264 is going to make it a super, like this is going to be smaller than some JPEGs. This will be smaller than one of the pictures you take on your phone. I usually choose, you get the option of display size here. You can choose from window, right? And we'll talk about this a little bit more later, but if you choose from window, that means whatever size your viewport is here, that's the size it's going to make your file, right? Your video. So if my window looks like this, then I'm getting this really wide file, right? I get something that's shaped like that, right? I can choose from render settings, and that will actually pull it from my render settings. In the future, that's how we're going to do this. But for right now, I'm not really too concerned on which of these you choose. I just want to be able to see it move. We'll talk about our render settings a little bit later today, and this option will make more sense to you. Right now, we'll go ahead and leave it from window. I'll go ahead and leave my channel box open and this open so it sort of keeps it a normal shape, right? Now, you all are on these really wide monitors, right? Which means that your viewport may be this elongated, like thin thing. And that means the video that comes out is also going to be this elongated, thin thing. For right now, that doesn't matter. Later, that'll matter when we're trying to control the way each of our shots look a little bit more. The last thing I want to choose down here is my scale. And for me, like you can leave it at 0.5. That means your video is going to be half the size of what we're seeing on our viewport here. It's going to scale it down by half, right? I usually turn it up to 1 just so I can see it the same size I'm seeing it here. Here is the important part. Okay, actually all of this stuff is important, but here is one of the important parts. I have to click Save to File. Now if I don't click Save to File, it's still going to make a file. It's just going to make it in some temporary directory inside of Windows that is buried deep under the like user profile or something, and we're never going to find it. So you're seeing that the movie file it's going to create is Play Blast. Where is it putting that? Anybody?
If you got your project set, it puts it in your movies folder.
So if you have your project set, it puts it in your movies folder. It puts it there with all of the other stuff, and you're keeping it organized. If you don't have your project set, who knows where it's going to put it, right? It's going to put it somewhere. So this is another reason to set our project, right? If for some reason you're at this point, you're like, crap, I forgot to set my project, you can hit close, go back up here to file. I guess we can kind of do it here. File, set our project, set it to the folder we want it to be in, right? But if for some reason you forgot to set it, you still want to know where this video is going to go, you can click this browse button, right, and it'll allow us to see where it's going to put it, right? Right now it's putting it in my users, Marlowe G, documents, Maya, projects, default, movies, right? Just where you thought it would be. Like, like it's in this long string of places. So it's still making it, it's still saving it. You just now have to go dig for it, right? Just for convenience sake right now, I'm just going to go ahead and put it under my documents folder, and I'll go ahead and give it a new name. I'll call it car video, or I'll call it car Marlowe G. That way people can tell what it is. Hit save. And you'll see now it tells me where it's putting it, right? And when I hit play blast, it's going to make that video file. Now really what it's doing is it's sort of taking a screenshot of each of our frames and then compiling that into a video, right? I hate this. Like for some reason, the MOV file, since QuickTime is not installed anymore, it says, well, you must mean you want to use iTunes. So I'm going to decline that. I do not want to use iTunes, but that means I have to go look for it, right? And you can tell where it went down here in the bottom. See, users, documents, Marlowe, or car Marlowe G. So if I go ahead and go to my documents folder, right, you'll see it made it right there. Look how small it is. 926 kilobytes. Double click on it. No, I do not want to open it in iTunes. So how do we not open it in iTunes? Anybody? So we can right click, open with, and Windows Media Player will work. Now here's something I will sometimes do. Like you'll have to do this every time you log into the computer pretty much. But if you just go down here to choose another app, it's going to let you always use a specific app to open it. So if I click that and choose Windows Media Player, now it's going to change the association and all of my MOVs will open in Windows Media Player. Right? And there's my file. Right. Okay. So you all have an option to, I'm going to give you a few minutes to go ahead and be play blasting that out, finding your file, and then uploading that to the network. I was kind of, I kind of called some people out on the bigger file here. If you want to replace that one with a smaller one, I'm not sure who that is. If you want to replace that one with a smaller one, I can always just delete that one later. That way we have more file size. I don't want to delete it now just in case it was somebody who turned it in and then had to leave class or something like that. I don't want to delete their assignment. And so these will still play. It's just the size of that is really big. So if we tried to play it right now from the network, it would probably play really jittery. Right? So then just go ahead and replace that one with one that's, oh wait, is this the same person? I bet it is. I'm going to go ahead and delete the big one then. Okay. Okay, cool. And so I go through this because this is something you're going to run into a lot at your time here at ETSU, which is you're gonna turn in your files, you're gonna try to watch them in class, and it's gonna play really jittery. Anybody know Marty Fitzgerald? He's the chair of the department. He just says it's kind of like after you learn how to do this, it's kind of bad digital manners to not do that. It's like we're going to run out of server space by the end of the semester if we're not careful. And so the more we can conserve that by compressing these, the better. What I have a tendency to do is in later projects, I make it a requirement that the file size is small, or I just deduct points, just to get you in the right habit of doing that. That way you don't fill up your hard drive so quickly, and you're kind of being efficient with your file space. So, all right. Now, while the last few people are kind of dropping those up there, after you get your file up there, go ahead and open it up in Maya, or I'm sorry, on your computer. And in a minute here, we're going to walk around and just see what some people got. Like, I'm just curious. This is always fun. I say, make 3 cars, make them move. Inevitably, some people went like, let's go big with this, right? Already walking around, I've seen a couple of helicopters or a couple of flying vehicles. That's awesome. And so we're like, that's kind of the point of this. When you find the thing you're enjoying, have fun with it. Do more of it. Right? While we're doing that, I want to make sure that everybody knows how to find the videos that we're recording for this class. So I'm currently recording this one as well. I showed you how to use WebEx. Anybody having any issues logging onto WebEx? Okay. I want to show you and make sure everybody knows how to find the YouTube videos that I'm posting every day after the end of this class. I'm not really posting a notification that each video is going up. Just know that at the end of the class, I upload the video, and so you should be able to find it after class. If for some reason you go there someday and you're like, "Hey, the video's not up," send me an email. Sometimes YouTube has some encoding error, and the email they send me about it goes to spam or something, and I just need to go work that out. I'm saving it locally on this computer, so that means if something messes up, I can always come back up here and re-upload it. But the place to find this is just on YouTube. Unfortunately, YouTube has a gazillion hours of video, right? To find the video to find the videos that I'm posting, I just post them all on one of my own personal channels. I basically took my personal email address, I split it off into a separate channel called Greg Marlowe Learning. So pretty much if you can remember my name, you can probably find this. So sure, let's allow it. I'm just going to type in Greg Marlowe. Let's see what happens. Okay, so I have 2 YouTube channels. This one's for stupid stuff. That one's where I post videos about learning. Right, so it's the green one. I may change that later and get an actual icon. But if you open that, it's just going to show you the videos sort of in reverse order of the last one posted, right? Some of the other things you'll see in here is stuff from my other classes. So if you're just curious, you're like, I need something to listen to, whatever, feel free to pop those open. Just kind of learn a little bit from osmosis. I have videos that I do for many, many different classes, all the way up to character animation, where I have one series about creating an entire animation set for a video game and importing that into Unreal where you can play it, right? So any of this stuff, if it's stuff you're interested in, even if you don't think you're going to understand it yet, feel free to watch it. You're not going to learn too much, right? You'll pick up something, even if it's just oh, that's where that button is, right? I want to make sure that everybody was able to find that. If you ever forget what the link is, it should also be in D2L under the links page, okay? I say that because a lot of the questions I get every day in class are already covered somewhere in one of those videos. And so I don't mind answering those questions, but I want to make sure that you are capable of answering them on your own when I'm not here, right? Let's say you have that question and this is a common issue you'll see in class. You'll be here at midnight some night and you'll be like, oh, I don't remember how to do a play blast. How will I ever find out? Oh, well, I'm going home. I'll figure it out some other time, right? Well, there's a video I made that has it in there. But let's say you can't even remember my name, right? You can just remember the word play blast. You can always search how to do a play blast in Maya, right? Look at there's a whole string of videos about how to make play blasts in Maya, right? Um, I show you this because you're all going to have different questions. This is not like, I don't know, like an algebra class where I can kind of predict the same questions that everybody's going to have, right? Everybody's going to run into different things. And one of the biggest things that you need to learn while in school is how to answer your own questions, how to solve your own problems, right? 90% of the time, when I'm not here to give you the answer, the first place you should go is Google, right? Like Google can answer almost all questions. Google can tell me what time my favorite Vietnamese restaurant closes. So if you just type in your question, even if you don't know how to phrase it, like just take a stab at it, you'll start wandering toward the right answer. And eventually you're going to get to a point to where everybody in this class has a different question, right? That there's not any two people who are asking or who are confused about the same thing. Some of you are going to be like confused about how to get a specific normal map to work on your texture. Some of you are going to be confused about how to adjust tangents in your graph editor. And all of those are different questions. I can answer all of them, but like that's just going to continue to happen the rest of your life. The thing to remember is that when you get hired, you're not getting hired to repeat a bunch of processes you learned in school, right? Like anybody could buy a book and learn how to to do these same processes. Like you're not getting hired because you know the secret formula on how to get a play blast out of Maya. You're being hired because somebody with money needs you to solve a problem, right? And the way you solve problems is to go find the answers even when you don't know them, right? So that's the thing that you kind of have to learn is like how to solve problems. And so we're going to work toward that a little bit more throughout the semester, mainly just by broadening the projects so you each have different problems, right? So you have to solve your own problems, have to sort of research how to fix the things that break in your project. Okay, so enough on that. That was just sort of my little spiel. So everybody should pretty much have a file up here now in the Playblast folder. Got a handful of new folders. It's all right. We'll remember eventually. You got to name it before you put it up there, and that includes folders as well. So let's go ahead and hopefully everybody has it open on your screen, playing in a loop. Let's just hop up for a minute and sort of stretch our legs, walk around, and see what everybody got out of this exercise. So I'm excited to see them. Even if yours isn't finished, go ahead and just sort of pause for a minute and just walk around and see what everybody else has got. If you've ever driven by the hospital and the helicopter's landing, that is how people react. Like they just swerve everywhere. Well, that's neat. So I think the no hurry, just meander back to your desk whenever you're ready. I think the more interesting thing is that it's such a simple assignment. 3 cars driving across the bridge. They have to drive a little differently, and you can kind of see where people got, for lack of a better word, excited, right? Like they got interested in a certain part of it, right? Some people got excited about the modeling of the cars, and they like put a lot of extra detail into their car, right? Some people start experimenting to try to figure out how to change colors on stuff. So we got a few people who had some different colors. Some people made a more elaborate bridge. That's cool. Some people just decided to put a little extra work into putting those keyframes on the animation to make the cars move a little bit differently, right? Some people, all of the above. Some people were just really enjoying possibly just working in Maya. Like, this is a neat experience. If you're none of those, that's okay, right? Like, I need to point out that like going beyond the requirements of the project was not a requirement of the project, but completely allowed. Anytime you're like, I'm enjoying this, I want to do more than the project asked for, yeah, absolutely, go for it. Like, I'm not going to like penalize you for having 4 cars instead of 3. I'm not going to penalize you for trying some new stuff. Recognize that in the process of that, sometimes you make some mistakes and you have to back up, and I can show you a better way of doing that. But that's fine. Like, that's where we learn, is from doing that. If you are one of the people who are like, I had no interest at all in going above and beyond on this project, that's good information for you to know too, right? Because you're taking 4 principles classes while you're here, and there is a good chance that you're going to really dislike one of them. And every person in this class, all the different people in this class will have different opinions on which one they hate and which ones they love, right? Some of you may be like, I love animation, but I hated the visual effects class, right? Some of you may be like, that's crazy. I love the visual effects class. I hated the animation class. And that's cool, because that's why we have 4, right? You don't have to be incredible at all of them. And one of the things you may learn from this class is that even though you like watching animation, you don't like making animation, right? A lot of people learn that about game design. They think that the process of making games and the process of playing games are somehow similar, and they're really not. Like, there's just a lot of difference between that. And that's one of the good. That's a good thing to learn about yourself, because then you can make better decisions going into the future, right? Sort of feel that out. Are you like, this is just okay. I'm really more excited about my visualization class I'm taking after this or whatever. That's cool. That's perfectly fine. I'm not offended. But you still have to do the base or the bare minimum to get through this class as well. Okay. Okay. So let's sort of talk about the things that are missing in this, right? I mean, obviously in mine, 2 more cars are missing. I just kind of, the file I had saved on my desktop, somebody restarted the computer, so it got deleted, and that was bad practice on my part. So I kind of threw this one back together from an old one. Some of you probably have different versions of this bridge. Some of you, your bridge may be green. Some of you, your bridge may be gray. I'd say the majority of you, the bridge is gray, right? So one of the things that's missing from this is color, right? And you saw that some people kind of experimented around with color. Just based off of sort of your experience in other programs, you would think that you could just grab that and color would be something you could change about it, right? Like if you've ever used Illustrator or something like that, you grab one of the objects and you're like, oh, I'm just going to change its color, right? Color gets a little bit more intricate in Maya, because it's not just the color we might need to change, it's the material, right? Like this wall is white, but so is, or whitish, this paper is white, and this remote is white, but they're all 3 different materials, right? We got plastic, we got paper, we got sheetrock with paint on it, right? All 3 of those are different materials, right? And so that's how we're going to work on the color of these objects. The other things we're going to look at today is the lighting of this, because those 2 things are kind of related, right? The way, the only real way we recognize that this is paint is, one, because it's illuminated, right? If this were midnight and all the lights were off, I couldn't see it at all, right? We have to have some light on it to know what it is. And when light hits objects, it reacts in different ways, right? When it hits the shiny lid on the top of my water bottle, it does something different than when it hits this paper, right? Bless you. And those are also properties of the material. Some of them are glossy, some of them are reflective, some of them absorb a little light, some of them are transparent. All of those are things that we have to sort of learn how to adjust. So we're going to learn a little bit about that, how to combine the lighting and the materials to get a pretty good looking image, right? Which kind of brings up the third part of this, is even if I put some color on this and put some lights in there, this is still kind of an ugly quality image. Like if you look, I got these jagged pixels in here. Like this is not a high quality image, or the word we use is render, right? If you think about that word, the source of that word, like there are other places you hear that, right? Anybody ever heard rendering fat? Has anybody heard that? It's like a cooking term. It's like you're basically boiling all of the fat out of something, right? And it's like extracting an element or extracting the elements from it, right? You'll also hear it used in terms of like drawing, right? The way you render something when you're drawing, right? And so render it, like the way we're going to use it is you're kind of combining the elements to get a single output of this, right? And for us, a render is just an image that combines the lighting and the material and all of the camera effects and all of the natural physical lighting effects to get an image that looks better than this image. Now, why does this image look bad? Why can't we just see it looking good right here? Any idea? Any of you play video games that are in 3D, like a first-person shooter, 3D games, whatever? PC? Any PC gamers in here? I'm a PC gamer. Sorry, I'm a PC gamer because I refuse to keep buying new consoles. So some of you have had that issue before where you start playing the game and it's a little laggy and you have to, you have a little bit of an older computer and you have to go and change some of the graphics settings. Anybody ever had that? Yeah, so you have to start turning things down. Why is it laggy? Like, why does a video game get clunky like that? Right. So we're asking Maya to do a lot. We're asking our computer to do a lot of math, right, or a lot of calculations at least, in order to show us this image. Right. We're kind of taking it for granted that we're able to see it, but if you think about it, right, the only information we're really giving Maya is that, right? There's a bunch of points in here, connect them with lines, right? That's the only real information we've given it. Everything else Maya has to like sort of fake in order to generate these shapes, right? And so it's creating these different surfaces on there for us to see, and it's kind of calculating how the light bounces off of all of those surfaces. And at this point, like, that's a lot of math for a computer to be doing, and so we can start dumping more stuff on there, but even more complicated, we're asking Maya to do all of that in real time, right? Because just like in a video game, I want to be able to tumble around here and it update in real time. And every instant that I move, Maya is having to recalculate all of that stuff to show me this image, right? So the less amount of detail I'm asking it for, the more responsive the program is. Right? Well, all of that light calculation that we were talking about earlier, that starts to really add up. When we first start doing renders, our renders may take 30 seconds to get a frame out, to get a single image out, right? So imagine like trying to tumble around Maya, but you have to wait 30 seconds every time you move your mouse, right? Like you would just never get anything done. So it boils it down to the simplest version of this. The nicest looking version is a final render, right? When we looked at this earlier, when I click this button right here, that little clapboard, it's going to give us a render. And although this isn't perfect, there's more information in here now, right? We got some shadows. We got a little bit better information about how this light is bouncing. Like this is much better than what we got before. So we'll come back to how to get a good render on this. But let's sort of talk about that conflict I just said there, because you can play your video game in real time and it looks pretty good, right? So the reason that is happening is because your graphics card is doing all of the rendering, right? And some of you have probably noticed in the 3D game, like you're running around and like there's some grass on the ground, and you look at that grass and you're like, that kind of looks like a piece of paper with a grass picture on it, right? And it's because that's easier for your computer to process than a highly detailed blade of grass with millions of them scattered along the ground and having to calculate all of that. That's too much for the computer to process and play back in real time. It's not too much for the computer to process and render over an hour, right? And so there's two different types of rendering that we're going to see in production. There's software rendering, which is a software package that's usually installed with the program, right? Maya actually has 2 or 3 that are installed with it, software renderers, that use the entire computer pretty much to generate a single image. Those images usually look much nicer, and you can have a lot more detail in there. If you wanted all of those blades of grass in there, you could render it. But your render time is going to be much longer, right? It's not uncommon, like in the real world out there of making animation, it's not uncommon for a single frame of animation to take 24 hours to render. Like one image to take 24 hours to render. There's 24 images in a second of animation, right? Your renders probably won't take quite that long, but it is possible that some of your renders will take 5 minutes an image to render, right? And so you remember when we were looking the first day of those things that past students told you to watch out for. One was to not underestimate how much time it's going to take you to render, right? I'll also show you that we have a couple of ways of sort of treating that. One of them is just start rendering as early as you can, right? Like if you can't always put the project off to the last minute because it may take 5 hours to render it, right? The other thing is we have what's called a render farm here, right? So rather than render one image on your computer every 5 minutes, right? And let's say you had 20 images to render, right? It's taking 5 minutes to render an image. Like that's a long time still yet, right? Like you're at least up there in a few hours, right? However, if you have 20 computers and each of them are all rendering at the same time, then it only takes 5 minutes. Right? It takes 5 minutes to render 20 images if you have 20 computers. The way people used to do that is come in here and log on to 20 computers and piss off everybody else in the building because they needed a computer too, right? The way we have that set up now is that we have, down in room 195, a whole wall of old computers, right? And we're calling that the render farm. That's what most people will call that. And there's a way that you can upload your files to the render farm so it can be rendering those. It's not easy. And most people really fight with that. And what a lot of people end up doing is just saying, never mind, I'll just render on my computer and wait on it, right? If you want to learn how to use the render farm, I'll be more than happy to work with you on that. If you go to the ETSU E3 server, under DIGM students, if you go up to student resources, it's the very top folder, there's a video in here called Render Farm Instructions, right there. And it's just a video that you can watch. It's a tutorial on how to use the render farm. Marty Fitzgerald used it or created it. He'll sort of walk you through on how to submit your file to the render farm and get your render out of it. The first time you do it, prepare for a few hours of working with this, but it will save you a lot of time if you get comfortable with that. Okay, so I've talked a lot. The biggest things we're going to cover today: materials, lighting, rendering, and then if we have time on that, I'm going to show you how to take those renders and combine those into a video using Premiere. Okay, so how many of you have used Premiere before? Okay, so basically Premiere is for editing video, but it can also recognize that a series of images might actually be a video that's just broken up into individual frames. And so you can import in your image sequence and then convert that into an MP4 or an MOV file. And so I'll show you how to do that. I'm not gonna rush it. So like if we don't get to that, I have a video that walks you through that process, and I'll just share that video on D2L for you to watch. So first and foremost, let's make this thing not gray. Like everything's gray, right? Let's make this thing some actual colors, right? So we can kind of choose the colors we want to use, but to start with, I'm going to go ahead and start with my car, right? This one's one that should be relatively easy. So we've mainly been looking in our channel box. If you select your object and you're just seeing these numbers over here, car body right here, right? This is the channel box, and you'll recognize, this may be covered up a little bit in the video. Let me move my face over in this. Okay. So you'll recognize that we have the channel box here, and if I click on this little tab down the side, I can minimize it, right? Below that, you may have another tab called Modeling Toolkit. Everybody's probably going to be a little bit different, but a whole bunch of different stuff can be opened in this side panel. In fact, we have like, if we go up above all of this, there's these 5 buttons here, and almost all 5 of those are going to open up below here. So the middle one, right there, it's like right next to the little person. The middle one is called the Attribute Editor. So let's go ahead and click on that and open it up. So the Attribute Editor still has a lot of the same information that is in the channel box, right? I would have to dig around in here to show you. Let's try a car body. Yeah, right there. So there's all my translates, rotates, scales, right? You'll notice all of these tabs along the top, okay? Each of those is what we call a node in Maya, N-O-D-E, right? Don't sweat too much about what that means, but basically the way to think of an object in Maya is every time we do something to it, Maya creates this invisible node that has some information, and that information is what is controlling how that object actually looks or works, right? And so right now we have a few nodes on ours, right? Mine has car body and car body shape, right? Both of those actually are just making the object. Like that's the one is like the location of it, the other one is sort of how it is rendered, right? And then we have this layer 1 node. This is basically where I added it to a layer. Not a big deal. Poly extrude node. This is where I extruded up those faces. And so each of these things have some settings to them. I could actually go in here and tweak some of those. I could hit divide and start to change. But you'll see that when I do, it messes it up. So I'm not going to worry about that too much. There's this poly tweak node. That means I moved some vertices. Like that's not really an important one either. And if I just keep going out through here, you'll see I have tons of them, right? This list will get huge, right? Like it's an enormous, like if you're modeling something really complicated, a human face, you may have literally thousands of nodes, which means yet again, Maya is taking all these different calculations into account when trying to show you this object. Sometimes we just need to simplify this, right? And so one of the things you can do is if I go to Edit, Delete by Type, History, it gets rid of all the unnecessary nodes, right? So let me show you that again from another view. I'm going to undo that, right, where all those nodes are at. If I show you from my channel box, all of these inputs down here are those same nodes, right? And so if I go to Edit, Delete by Type, History, that's basically telling Maya, forget all of that stuff I've done to make this object. Just think of it as a new object. Right? Just think of it as the same as you would a polygon primitive sphere, right? And so when I do that, all of those other nodes go away, and all I get is the car, right? So the thing I wanted to show you in the attribute editor, though, is the very last node. See it up here, Lambert 3. Everybody see that? Technically, I think it's pronounced Lambert, but I'm from Tennessee, so Lambert. This is your material. Okay. Here's the interesting thing. Yours may say something else. Yours may say Lambert 1. Yours may say whatever. The interesting thing is this is not an attribute of your car, right? This is a thing that stands by itself, right? We have a a material that can exist outside of the car. The Lambert 3 material will still exist even if I delete the car, right? In fact, you'll notice that if I go in here and select like the wheel, it's got the Lambert 3 node too, right? And so does the bridge, right? Which means if I go in there and start making adjustments to this Lambert 3 node, you see we have like color, transparency, all of this stuff, it's going to affect everything that has that node on it, right? So if I click my color here and change it to red, yay, my car is red, but so is everything else, right? Come on, undo that. What's happening? For some reason, it's not letting me undo the material. All right. I'll go back to gray just so we can kind of talk about it. So this is actually a beneficial thing, although it's a little bit of an annoyance right now. That means if, let's say we had an army of angry robots, right, marching at our hero character, right? There's thousands of them, and they're all rusty and like dirty and grimy, and and you spent all this time getting all these thousands of robots placed in this scene, and then the director comes back to you and says, you know what? We made a change to the story. None of them are rusty anymore. They're all actually nice and shiny and brand new. These are them coming out of the factory, right? Like, you just delete that file and start over. If they're all sharing the same material, you just change that one material node and all of the robots get that update, right? It's also very efficient, especially like this is the model that most 3D packages use. So in video games, you'll see the same grass texture over here and then later over here and then later in a different city, right? And that means you have fewer files that have to be calculated at one time, right? You may reuse the same brick in every city that you're in. So if we want our car to have a completely unique material, right, we need to give it a new one, right? So we can do that pretty easily. I want to show you this really quickly. Don't worry about how to use this too much yet. But up here next to our little render clapboard, if you go over a few, there's this like blue sphere with a dot in the center of it. If you click on that, it will open up our Hypershade. I don't know why it's not just called Material Editor, but our Hypershade. And this is all the materials that are in our scene. When you create a new scene, you'll only have one material, and that's the Lambert 1 material, right? Everything will have that material. If you want something to have a new one, you have to create it. This is an older file I've been playing with for a while, so you'll see a couple of new materials, right? So you'll see we have these Lambert materials, you'll see we have these blend materials. So one of the ways we could make a new material is to create it in here and then apply it to our object. And some of you will get into the habit of working that way. Sort of the easiest way to remember how to put a new material on an object, though, when you're first getting started, is to select the object and then right-click on it and go all the way down to Assign New Material. Yes, hopefully you can see that. It's kind of toward the bottom of the screen, but it should be Assign New Material. And when I release that, it's going to pop up this screen. Sorry about this, I don't know what this stop and shared thing is. I think that has something to do with the WebEx broadcast. So here's all the different types of materials I can apply there. You see the Lambert material. For now, don't use that one. We can talk about that one, but the thing to remember is that Maya is it's been around for a long time, and there's a lot of old things in here that some people still need to be able to use, but are not going to be relevant to you, right? There are still animated films that are being, that have been in production for years, and they're still using one of these old legacy shaders and rendering in a different render engine or whatever. When it comes to rendering for us, we have two different kinds of renderers three different kinds of renderers we can use, okay? We have Maya software, which is basically the first render engine that Maya ever used, right? Or Maya ever had. It looks bad, but it's really fast, right? So you get that trade-off there. Oh, it at least renders it, right? But it's going to look like poop, right? The shaders that uses is the Lambert and the Blend and the Fong. Like those are shaders. The reason they're named this is it's really based off of a physics person from history. It's named after them, right? Lambert was one of the first people to kind of think about how lighting falls off of a curved object or something like that. The Lambert material has no specular, no highlights on it. The Blend and the Fong do. But the renderer that looks best in Maya is the Arnold renderer. Okay, so if you'll notice in our presets here, we got Maya, and if I click that, you'll see the ones that work with Maya software, and then we got these surface. Don't really worry about those or volumetric that much. But all there at the bottom is Arnold, and you'll see the Arnold shaders all have AI in front of them, right? Yes. Don't have Arnold. Cool. That's actually good. I'm going to show everybody how to get Arnold if yours doesn't have that. So what you should have is these Arnold shaders, and we're going to choose AI standard surface. But before I do that, I'm going to show you what to do if Arnold is not showing up on your list. If Arnold's not showing up on your list, that means it didn't load correctly. It's nothing you did wrong. Maya just glitches out sometimes. In the process of starting up, it has to load a whole bunch of scripts. Sometimes one of them messes up and it doesn't load correctly. So if you need to load Arnold, we're going to close that. I'm going to go to Windows, and then Settings and Preferences, then all the way down at the bottom, Plugin Manager. Arnold is one of the things that sometimes doesn't load. Another one is there's a physics engine called Bullet. And Bullet sometimes doesn't load successfully. So if we go to the Plugin Manager, it's going to open up this. And you'll see all of these different plugins that didn't load. See, Bullet didn't load either. So it doesn't have the check mark on it. What we're looking for is, let's see. Oh, wait. I think it's toward the bottom down here. If we keep scrolling way down right here, it's down here by itself, MTOA. So it's Maya to Arnold, is what that stands for, right? And so basically Arnold is a plugin that kind of runs outside of Maya a little bit. And so this is the plugin that allows us to send files to Arnold. If yours isn't checked, then that means it's going to default to Maya software to render that. And remember, Maya software is the one that's kind of ugly, right? So if yours isn't checked, go ahead and check it. Now, before I go add that material to it, let's talk about rendering, right? So if I go ahead and click render here, right, you'll see that this is the image I'm getting out of there, right? And it doesn't look bad. We already have some shadows under here. We got some lighting that's hitting from one side. I actually put a light in there before I gave it to you just so it would render okay. And you'll notice along the top up there, you see where it says Arnold Renderer? That's the render engine that it's using to give us this image, right? So let's look at what the other ones look like. If I click this drop-down button and choose Maya Software and hit this little render button again in the corner, that's what Maya Software gives me, okay? All the shadows are harder. It's got way more like pixelation in it. And something that is not being calculated in here is how light bounces around the room. Okay? So kind of bear with me here and kind of just look around the room. Like look into the corners in the back there. You see how it's a little bit darker in the corners than it is everywhere else? If you take your hands and you put your hands together, you'll notice that in the crevices between your fingers, it gets darker in there. That's because light comes through these windows, bounces around the room everywhere, right? But eventually starts losing energy to the objects that it hits, right? And doesn't make it into all the corners, right? So light will bounce around, but those little crevices it doesn't make it to, right? Arnold is going to calculate all of that, and we're going to get that realistic fall off of lighting. Maya software is going to think of lighting as a just a straight line, right? It went in this direction, it hit an object, so everything behind that object has to be black, right? Like there's no light behind that object, there's no way light can go around this object because it's not calculating all of that other stuff, right? Thing to recognize is that this image rendered in Maya software in 1 second, right? It's probably not going to take much longer to render in Arnold, right? But it will take just a touch longer, maybe. Nah, it's actually saying it took less time. But as we get more and more stuff going on in here, Arnold's going to take longer to render, right? Because it's calculating way more stuff. Now, some of the other renderers that you're going to see in here, Maya Hardware 2.0. So Maya Hardware 2.0 is pretty much going to give you what's in our viewport, right? It gives us a different color background, but those images are going to be pretty much the same with a... okay. Oh, I tried to drag that off to another screen and it got confused. Hardware 2.0 is going to render really fast because it uses your graphics card to render. And it's going to look a little bit better than Maya software, but you have to do some tweaks on it to make it look good. So I can show you how to get an okay looking render out of Maya hardware as well. But Arnold is always going to be the best looking renderer. Okay, so back to Arnold. Let's start playing around with making some stuff, some different colors, right? So I'm going to go ahead and add a material to this car. Right click, assign new material. And the shader I'm going to use is the Arnold AI standard surface. Okay. You can play with the other ones. Like if I choose Lambert, it'll render in here. AI standard surface just has more options for us. So if I click that and hit render again, you'll see that it's a little different, right? But we're going to start seeing some of the things we can actually get out of that. There we go. Okay. Maybe the easier way is to move it over here. Okay. So I selected my car. AI standard surface is at the end, right? So the way we can think about this is that each of these little tabs are going to be a different element. Right? So base is the base color of this object. Okay? So let's say I wanted it to be red. I want to make a nice shiny red car. Right? Let me go ahead and choose red. Hit done. I can hit render. So now that's going to render as red. Okay? Just so we can see this a little bit better, I'm going to hit 3 on my car just to round it. It's not going to be the best model in the world. But we'll see that with that rounded, I'm getting a little bit of a highlight on there, right? And the color of the object is red. Some of the lighting is sort of falling off to the side, right? I can change this color to whatever I want to. Change it to blue, right? Done. Re-render. It's going to be a different color. You'll also notice my render time is now up to 3 seconds just by changing that color, but I'm getting a much better looking render out of this, right? So the thing that's kind of interesting is that each of these tabs, like the base color here, right, has a weight, which means I can turn that section up or down, right? So let's say I wanted it to be no color at all, right? I could turn that down and render this. And so I'm still getting the highlight, but my base color of blue is not coming through at all. Right? Or I could turn it all the way up, and it's going to be a little bit brighter of a blue. Right? Usually by default, it's set to 0.8. And that's just because if you set it all the way up to 1, it kind of looks a little bit like it's glowing. Right? Now, continually hitting render is I mean, it's nice. I can hit render and see a new version of it pretty quickly. But I want to show you a trick, and this is one of the things that makes Arnold really nice, right? Is that this is the render view, but Arnold has its own render view too, right? So if I close this down and I go to Arnold, open Arnold render view, and right now it's rendering nothing, right? But if I click this little play button, it's going to render it, right? Seems like it rendered it a touch faster. Now here's the cool thing about, like, that play button is on still yet. So that means any changes I make to my scene, Arnold is going to update in real time, or as close to real time as it can. So if I zoom out, it's going to keep trying to render this and showing me the new render. That way I don't have to keep re-hitting render, right? So let's go ahead and grab this. Hit F, there we go. I can also select objects from in the render view. I can click and select my car, right, the way I did. And so it highlights that. And I can go back to my AI standard surface. So the cool thing about this is now I can start making changes in here and seeing what those changes do, right? So I currently have my specular on, right? I can turn up my index of refraction, and you'll start to see it gets a little bit glossier. Can you kind of see that? It's not really showing super well. Or if I turn it all the way down, it looks like it disappears, but really what it did is it made it entirely reflective, right? Now it's like a chrome ball, right? And so we can just mess around with this and get different levels of reflection on this thing, right? I can turn up the metalness on this, and it's going to start turning it into more like a metal object. As I go down here a little lower, I can, well, let me turn up my roughness a little bit, and you're going to start seeing that highlight gets softer, right? So think of it this way. If you look at the monitors, like the backs of the monitors behind you, or maybe even like the desks, or kind of even the walls, right? Light is bouncing off of that and giving it a highlight, but it's not reflective. Like this whiteboard back here in the back is a good example. You can see the highlights on the whiteboard, right? But if you go and walk up to it, it's not a mirror, right? You can't like comb your hair in it, right? And so that's what we're doing with roughness, is we're keeping that highlight, we're just making it softer, right? If we make it harder, it makes the object look glossy, right? Like the lid on my bottle or a bowling ball or something like that, right? And we keep going down here. Transmission is going to make it sort of translucent, where we can start seeing through it a little bit. You can't really see that well. Some of this is because of the background I have in here. And so we got a whole bunch of different things. Subsurface is interesting. If you'll notice it more on your way home, but like if you hold your hand up to the sun, you'll notice that like light passes in between like the thin parts of your skin, right? It also, you'll notice it in like milk, right? Like if you put a flashlight behind a glass of milk, light will come through that, but it's not transparent, right? It means that the light is absorbing into the object and sort of bouncing around and then kind of coming out, right? And so that's what subsurface is we can turn that on and off. And by doing that, we can make the object start to feel a little bit less like this solid, like plastic thing, and a little bit more like it's made of more organic materials. Coat is really just another highlight. If you want to make this thing super glossy, we can have two sets of highlights on it. All right. And emission is how we make it glow. So if I turn this up, I can pretty much turn my car into a light, right? You'll notice that underneath the car now is illuminated and stuff like that, right? So using all of these different materials, we can pretty much make any material we want. Right? But I want to point something out to you. At the end of each of these is a little checkerboard. See that little checkerboard? At the end of color there, it's just like a little black and white checker, right? Let's go ahead and click on that. Let's see what happens when I click on that. So if I click on that, it brings up this thing, and this seems similar. This is very similar to when we picked up the materials, right? But this is the option for me to make, instead of a solid color of blue, for me to map in an image, right? And so a lot of these images are procedural. So for example, let's try noise. So if I map in noise, now I get kind of this like cloud pattern on here, right? And I can turn my threshold up and down on this and my amplitude and all these different things. I can also even go in here and change the colors. Like I can make it a green and blue noise, right? And so I can start making like my own procedural textures on there, right? You'll notice that if I go back to my material of my car, right, now instead of a checkerboard, there's a little arrow there. And what that means is it's looking for this noise, right? That's what's connected into it, the inputs and outputs. I can also click this button and it'll go back. Now let's say I do that and I change my mind. I can right click on color and say break connection, and now it just takes it back to a solid color. It shows the color that was closest to what we wanted, right? So let's say you right click on the word color, or whatever it is you mapped it into, and say, oh, there's no connection there anymore. Let me undo that until I have it again. If you right click on color and say break connection, it will disconnect it. All right. So, but let's say what you need is actually a photograph, right? Let's say you have a picture you took with your phone of a brick texture, right? Or a picture you took of your phone of whatever, like some grass outside, or an image you drew in Photoshop, right? Let's say you went into Photoshop, you made like an Illustrator, like a very cartoony version of a brick texture, and you want to put that on an object, right? One of the options inside of here is File. So if I click that checkerboard again, you'll notice right there, fourth from the top is File. And that's probably the one you'll be using the most. And when I click on it, it'll take me to here. And then it'll ask me, like this image name here, it's looking for an image for me to map into here in order to be able to see it, right? So by default, this is going to put it in our project, right? So if you went to File and you set your project at the beginning, it's going to put it in your source images, or that's where it's going to look, right? So if I go click on that, see where it went? Source images. And it's going to my default folder because I didn't set my project. It's looking in the default project file. Now let's go ahead and save this here really quick. I'm going to save scene as. Let's say I don't have a project folder, right? Let's say I haven't made one yet. I'm just working with this. I'm going to go ahead and create a new one, right? So if I go File, Project Window, right? You're going to see this is where it gives me the option to create that project. I'm going to go ahead and hit New, and then I'm just going to guide this to my documents or something like that, right? And say Select. And I'm going to call this Bridge. Right? So notice that I'm going to just go show you this really quick. In my documents right now, there is no Bridge folder, right? But when I hit Accept, it should have, yeah, it created a Bridge folder, and it created all of the folders I need underneath there as well, right? So now it also set my project to there. It should have. Just in case, we can go File, Set Project, choose Bridge, and hit Set, right? And so now if I wanted to save my file, File, Save Scene As, look at that. It goes straight to Bridge Scenes, right? So I'll go ahead and call this Car Save As, right? But when I want to put a material in here and click there, now it's going to go to Bridge Source Images, okay? Now your Source Images folder isn't where you have to keep your textures. It's just the first place Maya thinks you're probably going to put them because a texture is a source image, right? So let's get one. Let's go find us some free textures. So your first instinct is to type in brick, right? And look at that. Look at all those free textures, right? But are they? So let's say I went into your dorm and I was like, whoa, check out this free PS4. And I took it and I walked out. Just because I can find it doesn't mean it's mine, right? And this is a freaking epidemic in the world today. I literally know people whose artwork is being printed illegally on other people's t-shirts. Like there are companies who just found their artwork online and just started making t-shirts and selling them of that picture. They never asked them. The way they found out is they saw people wearing that t-shirt. The person I'm thinking of, she's an incredible concept artist, and they're just stealing her work and making money off of it, right? That would be what we're doing. This actually happens in the industry as well. Like there have been people who have been sued, companies who have been sued because they saw their own vacation folder or vacation photo in the background of a feature-length movie, right? And they're like, I took that picture of those trees and now they're using it as a texture and they never asked me because they found it on Google. There are very easy ways of getting around this legally, right? Which is, there are plenty of companies out there who want to make these things for you to use, right? So you can buy like subscription services to all of this reference image that is completely free to use. But I'm not going to have you buy things right now. You can also like take your own pictures. That's actually the way most people do it. Is if they need this source image, they go find it and they have complete control of it. Then, right? But if you're just kind of in a hurry, like we are right now, textures.com. Not textures. Oh, that was a close one. Textures.com. Right. There we go. Look at that. Now, they do want to sell you stuff, but they'll give you so much of it a day for free. Right. So if you'll have to create an account. I already have. Right. And I think you can download something like, I don't know, it's like 15 megabytes worth of free images a day. And there's only certain images you're allowed to download. But let's say I needed, let's try something that's going to be noticeable, right? Let's go ahead and try brick. Brick isn't going to make any sense on this car, but we'll try it anyway. Let's try this rounded stone here. Yeah, this one's one that is a very noticeable texture, right? So there we go. We have a whole bunch of free options. Now, if you want the really nice big ones, like it's going to cost you, but you get so many free credits a day. So I'll go ahead and get this medium free credit one. And I'm going to put that in my source images. Okay. So documents, bridge, source images, save. And so this is the image I just downloaded. And if you zoom in on it, you'll actually see it's relatively decent. Like it's enough for what we're going to use it for, right? So, see, when now I go to my folder here to find that, it takes me straight to source images. There's my source image. And when I hit open, it puts it on my car. And it looks really ugly. But that's okay. We're going to get to some of that later here. Now, some of you may have done that, and you still don't see the texture. Okay? So this is where I kind of remind you of this. 4 is wireframe. 5 is shaded, which means we're going to be able to see the highlights. We're going to be able to see if it's transparent or whatever, right? 6 is textured. Okay? And then 7 is lit. 7 means we got a little bit of lighting in there. Okay? So 4, 5, 6, and 7, that's how we're going to bounce around to there. Now, the thing you'll notice about this is it really did not apply that in any sensible way to that car, right? We're going to talk about this later, and we'll talk about it in a little bit if you need it in this project one-on-one. But the way Maya thinks about that is the same way you would think about wrapping a birthday present, right? So let's say let's say I bought you this shiny new remote for your birthday, right? I'm going to wrap it. Right? My go-to is I actually just drop it in a bag because I hate wrapping things, right? But I have a flat piece of paper that I'm trying to wrap around a 3D object, right? And there's an infinite number of ways I can do that, right? And get a different result every time. It's never going to quite wrap around it perfectly, though, is it? Because wrapping a flat piece of paper around a three-dimensional object is always going to leave us little corners hanging off and stuff like that. Anybody ever tried to wrap a basketball for Christmas? Yeah, it's a pain in the butt. It's easy to wrap a perfectly square box, right? It folds around it pretty nicely. Wrapping a basketball, like how I always do it is I just put the basketball in the middle, pull it up, twist it, and knot, right? It's hard to wrap some 3D shapes, right? And this is what's happening here. Our car is trying to, or our Maya is trying to wrap that 2D texture around our car, and it's doing a meh job, right? The way we fix that is by adjusting what is called the UVs, the two letters, U and V, right? And what that is a way of, like, all of these 3D points, it's a way of unwrapping it to where we know which point, which vertex, which edge lines up with which part of the image, right? It is, I will warn you, it is the part that most people hate in terms of materials. Like, most people are like, oh, that's such a pain in the butt. We'll look at that a little bit more later. Don't sweat it just yet. What I would say is, like, as we're working through this, if you start running into issues, I can help you one-on-one work through your UVs. And then later in Project 3, maybe a little bit in Project 2, we're going to talk about UVs. So I'm going to kind of dole that out kind of slowly so it's not overwhelming, because it can get overwhelming. Recognize we don't have to have a texture on everything. You know, a car doesn't usually have a brick on it, right? Cars are usually a solid color. I also want to point out that this is mapped into the color, not to the shininess or anything like that, right? So if you go outside and you're like, oh, I want my car to look just like my car, and you take a picture of your car, you're taking a picture of the highlights, you're taking a picture of the reflection of that tree that's in your car, and once you wrap that around your car model, right, all of that stuff is going to be permanent instead of changing like it really does in real life. So, so what I'm going to do is I'm going to go in here, I'm going to go ahead and break that again, right? And I'm just going to set this to a color that I like, right? And go and open back up my render view, hit play. And so we're getting a pretty decent result there. To try to get that color, that car look, I would go about adjusting all of these presets instead, right? Now, something I do want to show, or not presets, these values. Something I do want to show you, though, is that there are some presets, okay? Again, these are going to be heavily affected by the lighting in the scene, and we're going to talk about lighting here in just a second. But if I go to my presets, you'll see that I have some options that are kind of like defaults here, right? There's a car paint option, there's a brushed metal option, there's a blood option, I don't know what it is. There's a clay, chrome, copper, glass, gold, honey, jade, right? These are all like interesting materials, right? Recognize that none of them are brick, because brick is a texture that is on a stone material, right? So let's say I chose jade. I just highlight jade and hit replace, and you'll see that it sets it to all of the presets that are needed to make this object look like jade. It's way brighter on my screen than it is there, so we'll work on that here in a second. I want to undo that. Let's go ahead and set my preset to ceramic, right? So it's a little bit of a, you know, so there's a couple of different options we have there. Okay, we can do this for all of our objects, right? Again, I select the object, I right click, I assign new material, shader, AI standard surface. Right? And so you'll notice that it's a lot shinier now, right? I don't really want it to be shiny. I'm going to make mine a little darker, and I'm going to turn all of my specular off or at least I'm going to make my specular very rough. Right? And so maybe that's my road. I may want to go put some stuff on it later. Now let's say I wanted to apply that same material to all of these. You'll notice that that material is AI Standard Surface 2, but I can highlight that and call this Road MAT for material, right? And so now when I select this other object and right-click, I can assign an existing material and just click Road Material and assign that same material to all of these other objects. Okay. So I'm going to go ahead and just, for the sake of being able to play around with lighting, I'm going to go ahead and delete the current existing light in here. So if you're looking in your outliner, I have this directional light right here. And so I'm going to highlight that and delete it. And so I want to point out that Arnold is still rendering. It's just rendering the darkness, right? Those objects are still in there. It's just we can't see any of them because there's no lights in there yet, right? So let's talk a little bit about how to do some lighting in Arnold, okay? So I went ahead and closed my render view just so we can see here. There's a couple of options that we will use a lot. But for me, we have these create lights over here. Some of those will work with Arnold, but some of them just don't have the best results. If you want the best results in rendering, we're going to go Arnold, lights, and we're going to use these lights. Okay. One of the cool things about Maya is if you ever see this little double line across the top of a menu, that means I can click that line and break that off, and now I have a copy of it right there that I can keep with me, right? So the two I'm going to talk about right now is the sky dome light and the area light, okay? And we're going to look at the results of both of these. Let's start with the sky dome light. So if I click the sky dome light, an interesting thing happens. Maya creates this giant sphere around my entire scene, okay? And if I go back to Arnold and open my render view and hit render, now we're getting this like more brightly illuminated scene, okay? This is not necessarily how the sky dome light is intended to be used, but this works pretty well if you want to just be able to see what all is going on in your scene, right? This basically means everything is casting white light in all directions. That's not a world we usually exist in, right? Like, there may be some white light coming from the sky, but there's green bounce light coming from the ground, and there's, you know, some blue in there, and like, there's a lot of different things going on, right? This is like, I rendered my car in that Dumbledore scene at the end of Harry Potter, right? Like that's what's happening here. The reason we have this sky dome light is because we can capture environment information, right? We actually have a camera that Professor Livingston downstairs just recently got a grant to purchase that allows you to capture full 360-degree image at any given point, right? Well, we can map that information onto the sky dome and use that to illuminate our scene as if we were really there, right? It will capture lighting from a photograph, and we can have a similar lighting that we would have in that actual environment. This is how a lot of visual effects are done, right? Having said that, though, it's very like sterile, right? If we look at this scene, like there's not a lot of personality in this, right? But it is a nice way of being able to see what your scene looks like. Like any other light, I have some options over here. I can adjust my intensity, okay, which means I can make it brighter and I completely wash this thing out, right? Or I can make it darker. I can make it kind of very gray, right? Or I can change the color of it. Let me go and set that back to 1. And I can make it, instead of white light coming from all directions, it can be red light coming from all directions, right? And now we're in like some sort of weird, like, trippy room, right? I'm going to go ahead and delete this, though, because you'll notice that it's actually just an object in our scene, the sky dome light right here. So the other kind of lights that we were just talking about are area lights. And those are a little more, like they're not going to give you a great result immediately. You have to be in control of those. But these will have some really nice effects. So if I choose area light, it created it back there at my origin point. I can move it up. The thing you'll notice about an area light, two things. It's a box, right? So think of this as these lights above us, right? The shapes of these lights above us is sort of a rectangle. Right? And it is casting light in a specific direction, right? The way we can tell which direction our area light is casting light is that little that little line that points out from it. So if I deselect it, you'll notice one side has this little red arrow that points out. That's the direction it is casting light. Okay? So I'm going to go ahead and sort of rotate this thing around to be pointing at my car. Right? Something like this. And the size of this will change how the lighting works as well. So if I go in here and I hit Open Render View and hit play, I don't know if you can see, but it really faintly illuminated right here. It's really faint, right? So I need to turn up the intensity. Right? If I start turning up the intensity on this, it'll start getting brighter. You probably still can't see it, right? And keep going, keep going. You're starting to see the car a little bit, right? But my intensity is at 10. That seems high. Like if I type in 100, now we're starting to see stuff. A lot of this has to do with the size of the light in comparison to the size of your scene, right? And so if you modeled a really enormous scene and you put a light bulb in there, right, you can't illuminate an entire village with a single light bulb, right? So what we need to do is, we could leave that at 1, right? But it's this button right here that we got to watch out for. It's normalize. And so if I uncheck normalize, even while it's at 1, I start getting a little bit more of a result, right? So I can, again, turn up my intensity, start getting some more lighting information on there, right? Exposure will do pretty much the same thing too. It also turns it up. So you could always leave your intensity at 1 and turn your exposure up instead, right? Right? And so we're starting to get a pretty nice looking render. So the things I want to point out here, a couple of things, is that we're getting sort of these softer shadows. Like it's not just a perfect hard line. And that's because it's calculating all of that bounce light, right? We're getting areas where the lighting is kind of falling off. Some of the things you may notice that do not look good, though, is the fact that we're also getting some grain around here. You see that? Like it's very noisy, right? So what's happening is this light is casting a bunch of points of energy, right? And we call those points how many times it's going to sample, right? It's going to bounce around the scene and sample where the light should go and give us a render as a result, right? Well, the more points it casts out, the better of a result we'll get. Right now, my samples in my light, again, this is the object I have selected, the area light is selected. The samples are 1. It's casting like 1 sample per photon or whatever, right? And that's why we're getting a little bit of that graininess. If I crank that up to something like 5, I'll get a better result. However, this render just took 2 seconds. If I crank that up to 5 and hit enter and it re-renders, still rendering, there we go. It took 4 seconds, right? And so it's going to, it looks better, but it's going to take a little bit longer. And so that's the thing we have to be careful with our lighting and with our rendering is how long this is going to take, right? Now, something you can notice, my light is an actual physical object in here. And so I can move that around and get different lighting results, right? I can also parent that. I could parent this underneath the car control and create headlights. And I can scale this, right? If I wanted the light to seem like it's coming from a much smaller object, I can scale it. My shadows will probably get harder and like less, blurry, but my light amount is smaller, right? Or I can make it much bigger, right? And pull it further away. And so the amount of light that's coming out is a lot now because it's bigger. But I'm also illuminating more of the bridge now, right? Now, this is just one light. Right? So we can have as much control as we want of this. I can go and hit stop on this just so it's a little bit more efficient. And I'm going to go ahead and duplicate this light. Anybody remember the shortcut key for that? Control D. So I just made a duplicate of that light, and I'm going to move it over here and maybe rotate this around a little bit. Right? And so now, when I get in here and render, I'm going to get a little bit of a different result. So now I got some light coming from both directions. Right? And I can adjust both of those however I want them. Right? Now something else that's kind of cool is I can actually make these lights different colors. Right? So I could grab this light here and I could change its color to blue. Right? And you can see one light's casting blue, and I could change this one to red. One light's casting red. This is not a very realistic environment. It's a little bit more of a like a club environment or something like that. So I'm going to go ahead and change both of those back to white. There we go. We can also use this color temperature, which is just really faintly going to give it a color. Right? So I can make it a little bit of a cooler light coming from one side and a little bit more of a warmer light coming from the other side, right? And that's a way we can kind of get a slightly more there we go. Okay. So I'm rendering this all out. Last few things I want to talk about is the size of my render and like the settings for this. So I've been doing this all without really controlling the overall settings of the shot. I'm going to go ahead and close this. So this button here is how we render. This is going to render a single image, right, of this. Right. So we've already learned that. We learned that this little blue ball is the materials, right? So those two new materials we've made, you know, they're there. The AI standard, the road material, right? Right next to that blue ball is another clapboard with a cog. You see that? This is our render settings. So if we open up our render settings, this is going to give us a lot of information, okay? And in a minute here, we're going to need to, or in a little while here, we're going to need to render out an image sequence, okay? This is where we'll be able to control that. So right now it's going to render out a file format called EXR. And EXR is the type of image we're going to use, but I don't want to go in that too deeply right now. I'm going to kind of sort of expedite the rest of this. If we scroll down a little further, you'll see which camera it wants to render from. So right now it's from our perspective camera. Right? If we had another camera we wanted to render from, we could change it. You can see the preset for the image size. Right now it's HD 540, which means it's rendering 960 by 540. As a point of reference, you cannot buy a TV that will show an image resolution that small anymore. Okay, so you probably are never going to need it to be that small. This is roughly like the lowest, one of the lower settings on YouTube, right? Like when everything's all blurry. That's the image size it's looking for. You know, when you go to buy a TV, it asks you, you know, like you hear people say HD 1080 or HD 720. If we go to HD 720, you'll see that that's 1280 by 720. That's 1,280 pixels across and 720 pixels up and down, right? And you'll see that if I set it to that and render again, my image gets a little bigger, right? And we're able to see a little bit more detail in there. My render also gets a little slower, right? So let's see. At this resolution, now we're looking at about, it looks like about 16 seconds for an image, right? And then, of course, HD 1080. This is not the highest by any means, but this is more of what you're going to see on most of your TVs now is at this resolution. So if you want to make this into a file, you can show your family on your TV at home. Render it at the big one, right? This is one of the default HDs that we're kind of gravitating toward now. You will recognize though that this render time is going to be significantly slower. Okay, so I'm going to go ahead and let that finish so we can see the number on it. So that one took 36 seconds to render an image. Okay, so some quick math, just so you're thinking about it. Here. 36 seconds. Let's say we have 10 seconds of animation, which is 240 frames, times 240 frames, equals 8,640 seconds. So we'll go ahead and divide that by 60. That's 144 minutes. Divide that by 60, approximately 2.5 hours. All right. So that's just an idea of how long it would take to render at this resolution what I have on this scene right now. For this first project we're going to be working on, I'm cool with you rendering as low as HD 720. I would like to see it in 1080, but we can go to 720. So let's talk about that. So I will share a video later today that shows you how to turn all of these images, once you have them, into a video file. And we can also talk about that next class period if you'd like to. But I want to give you some work time next class period. I'm going to go ahead and go into D2L really quick, just so we can look at the project. So I'm going to go here, Principles of Digital Animation. Something I would mention, even though I spelled it wrong, we have a subscription to Gnomon right now, so you can use that as supplemental videos. A lot of those are higher level videos that you're going to find more helpful later this semester than right now. I do think that there is an intro to Maya video in there, but somebody told me it's 19 hours long. That might be a good way of going through and skimming it and just watching the sections you're most interested in. So again, here's my YouTube channel link. We talked about that at the beginning of class, but right here is what we're going to today. PR1 Bridge, right? I'm going to go ahead and open that in a new tab, if it'll let me. Yep. And I'm also going to open up, do I have that? I thought I added our schedule in here. Okay, I didn't. I will open it just to show you though. Oh, did I put it in? Is it? I thought I had a daily schedule on here. I'll pull it up. I may go ahead and share this with you as an image.
It's under course schedule.
Oh, there we go. It's not under that. Okay. There we go. So, so here's the bridge project. Some of you maybe... Here should be the bridge project. Links.
That file always just opens to a blank. I've looked at it on these as well.
Interesting.
I got a Word document.
Let me fix this link. Oh, that's not where I wanted it to go at all. I didn't realize that was dead. If you find other dead links, let me know. Because this is just a Google Doc that I have. So, ATS classes, POA. Update. So let's try that again. There we go. So now it should open up for you. And this is what you should see. Let's zoom in a little bit so you can read it. So this is project 1. We're just going to continue to build off of the thing we have right now. But we've pretty much covered everything that you need to be able to turn this into a relatively decent animated scene. I wanted to get more covered today, but I also wanted to take it kind of slow. So next class period, I'm going to have a short lecture over how to compile an image sequence. And I'm going to do a little bit on how to animate some camera motion so we can create a new camera and move that around. But then for the most part, the rest of this is just me cutting you loose and letting you run with it, okay? So what we're going to be doing, why we're doing this. I always like to start with why so you understand that I'm not just like to keep you busy for the rest of the semester. That's not why. There's reasons to be doing this. The purpose of this project is to allow you to explore all the basic elements of the animation pipeline so you can learn the basics and start to get an idea of what part of the process you enjoy the most, right? With the exception of effects animation and really some detailed rigging, we've gone through the entire process of creating an animation now, right? We still have to render this out and see how to do a batch render and that sort of stuff. But like we've gone from everything from creating the objects, moving the objects, putting materials on it, lighting the objects. Now all we got to do is render it, and that's the entire process. That's a very simplified version of what Pixar does for every movie they make, right? We're going to just keep reiterating on that as we go through the semester and learning more and more details about each of those parts of the process. So what we're going to be doing, using the 3 animated vehicles and the bridge from the first 2 exercises, create a full scene, adding in additional models, lights, materials, textures, animated cameras, and other animated elements to make a completed animated shot. So make the scene your own. Some things you can consider. I don't want to say everybody has to do all of these things. I want you to sort of run with the stuff you're enjoying the most. Add an environment, including a sky and surrounding terrain. That is one that you probably should do in some form or another. Otherwise, it's just a bridge floating in space going from nowhere to nowhere. That doesn't make sense, right? Add additional vehicles or animated objects. Some of you have already done that, right? Adjust materials to make the scene feel more realistic. Light the scene in a way to create a mood. Add a camera motion or cuts. And make sure your bridge is going to and from somewhere. What is it crossing? Like, is it crossing over a gorge of spiky boulders, or is it crossing over a small pond? Each of those are going to present their own challenges, right? A pond means you got to figure out how to texture water. Spiky boulders means you have to create more models. Right? And eliminate any telltale signs that this is not a full 3D world that the viewer is watching, right? If I can see the edge of your mountain and where it falls off into the abyss, I'm like, you break that that feeling that I'm actually in a world, right? So try to convince me that I'm in a world. I would say most of these are advisable, right? You may be able to frame your shot to where you don't have to do all of them, but try a little bit of all of these and just convince me that you've created an entire world for these for this scene to exist in, right? The key to this assignment is to use the previously created exercises as a starting point, but you're completely free to redo or rework the previous models or animations. If you look at your bridge and you're like, you know what though, I want this to be happening on London Bridge and I want it to be like this like British bus, like that's cool, like go for it. Like this should be a little extra work, right? So if you want to do a completely different bridge, model it. If you want to do different cars, model it in animation, do it. The finished piece should be a fully rendered 10 to 12 second animation at a resolution of 1920 by 1080. If that render is taking too long, you can do HD 720. Okay, just for this one, we're gonna bump it back up to 1080 as the semester moves along, just for quality reasons. I wanted you to see how this is graded. This is actually a picture of what I use to grade this. Okay? Every project in this class is graded via a rubric listed below. You have 5 criteria and 5 potential points per criteria. The total grade will be 25 points. So basically, the modeling is it excellent, good, fair, weak, poor, or incomplete, right? And I just go through and click, 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 and it tallies you up a grade, and then I give you some feedback at the bottom of it. This is in D2L. You could probably even find this rubric in D2L. No, it's a little faint on here right now. But you will get this after I grade it. And then whenever you turn in a revision, you'll know what to be working on. If the animation was way down here at 1, you can be working on the animation for that revision and bump it up to a 5. Right? So you see how you can grow in this grade. So I think technically we're out of time, so I'm going to go ahead and shut up. When is this due? It's a week from today. That's one of the things from the schedule. So right now we are on the 10th. We're going to be turning it in a week from today on the 17th. So I'll go ahead and put that in there. And you're free to go if you need to run out. So.
Before you go, I need a hand. Somehow one of the support thingies on my bridge is glowing, and I don't know how I did it.
Okie doke. Give me 1 second to save this, and I'll be right there.